Hello, so welcome to our review video for exam 3. As always, use this review video as an opportunity to identify areas of future study. Always pause a problem when it appears on the screen, try it on your own, and then you can unpause to check your solution. So looking here, let's start with this problem, multiply the following matrices. Now, whenever you multiply matrices, you always go to the second matrix and you start with the first column. And imagine we're bringing this first column up, and then if we could turn it 90 degrees over to the left, and imagine it's kind of floating above here. So we've lifted it up, turned it over, and now this is going to multiply by the first row. 6 times 1 gives us 6, plus 3 times 3 gives us 9, and that's the first row, first column of the new matrix. Now, this 6 and 3 gets multiplied by the second row. 6 times 0 is 0, plus 3 times 7 is 21. And now that we've gone through all the rows with our first column, we do the same thing, but now with the second column. So imagine taking the second column, lifting it up, turning it 90 degrees to the left, and this 2, 5 is going to go multiplied down through the rows. So 2 times 1 is 2. 5 times 3 is 15. Add those together. Now this continues down. 2 times 0 is 0. Plus 5 times 7 is 35. Now we're going to complete this addition. 6 plus 9 is 15. 21. 2 plus 5 is 17. 0 plus 35 is 35. And this is our new matrix. So next we have a system of equations, and then we have 4 answer choices, and we're asked to select which correctly represents the system of equations as a matrix form. And personally, I'm always going to do the problem first and then check my answers. If I just look at the answer choices, I'm liable to miss a small detail. So whenever you rewrite the matrix, whenever you rewrite a system in matrix form, you take the coefficients first, make sure the x's are lined up, the y's are lined up, the numbers are lined up. This is great. We can work with this as is. What's in front of an x? An implied 1. 3 is in front of the y, 6, 5, and 2. And all of this joins the first equation becomes your first row. 2, 3, with a bar to indicate the equal sign, and then the 5. The second equation becomes your second row, so 1, 6, and 2. And remember, if there is no variable here, if for instance there was no x, we would put a 0 here. But as there is an x, we put a 1. I look which one of these matches. 2, 3, 1, 6, 5, 2. And I believe that would be B. So now we have this problem in reverse. We're given the matrix and we're asked to rewrite it as a system of equations. So I know I'm going to work one row at a time. So this will be -1 goes in front of the x because that's the first row, first column, plus 1 in front of the y. This bar turns into the equals 3. Okay, now at the next row, that's 6x plus 5y equals 2. Now let's look at our answer choices. And remember that -1x is just the same as -x. 1y is the same as y. That's written with the implied 1s and -1s. So I believe that will be D. So here we're asked to find the inverse matrix, and I have a little bit of a reminder included at the bottom for us. So to find the inverse of a 2 by 2, remember this is a 2 by 2 because there's 2 rows and 2 columns. To find that inverse, we would first use this formula. This is definitely a formula that I would have memorized or written on my personal formula sheet. And the A is always the first row, first column. B is first row, second column. C is second row, first column. And D is second row, second column. So A inverse following this formula will be 1 over, and another way you could remember it is it's AD, the first diagonal, minus BC, the second diagonal. 5 times -1 is -5. minus negative 3 times 2 is negative 6. And then you multiply this throughout the entrance where you, okay, the way I remember it is you switch the order of these. That's why D and A have switched positions from their original A and D. So negative 1, 5. And then the off diagonal stays in the same place, but do you see we now have negatives? So you negate what was there. So this was originally 2, now it's negative 2. This was negative 3, now it's 3. Now 5 minus negative 6, that is the same as 1 over negative 5 plus 6 times the matrix negative 1, negative 2, 3, 5. Now negative 5 plus 6 is 1, so this becomes 1 over 1 times this matrix. But this matrix, 1 over 1 is just 1. 1 times anything is itself. So my A inverse is just the matrix negative 1, negative 2, 3, 5. So next up we have two questions. Is the series arithmetic, geometric, or neither? So I'm going to check both the arithmetic and geometric first. If it's neither one of those, then it's neither. Remember, for arithmetic, that's can you add? Think starts with the A. Arithmetic, add. Can you add or subtract a common value? Geometric is the other one. Can you multiply or divide a common value to get the next term? So looking here, if I'm going to always check the arithmetic first, unless I just see a pattern that's geometric, because it's easier to tell addition and subtraction, if that's what it is. 18 goes to 16, well, I'd subtract 2. Let's see if that pattern holds. 16 goes to 14, I'd subtract 2 again. We're good so far. Let's see if it keeps holding. 14 to 12, I'd subtract 2 again. 12 to 10, I'd subtract 2. Each time here, I subtracted 2. I've kept a consistent pattern, so this is arithmetic. Now for the next one, if I was thinking about checking the subtraction, to go from 4 to 2, I'd subtract 2. But do you see to go from 2 to 1, I'd subtract 1? At that point, I can't add or subtract a consistent value for this one. So it's definitely not arithmetic. So let's check geometric. To check geometric, you can either see it or always remember to do the next divided by previous in your calculator. So let's check that. So the next one is 2. 2 divided by 4 gives me a factor of 1/2. Let's see if that's consistent. So the next one, we've got 2 to 4 is divided, or I guess divided by 2 or multiplied by 1/2, whichever way you want to think about it. Let's check the next one. Next divided by previous, again we get the 1/2, so this is again multiplied by 1/2. See if it keeps going. 0.5 divided by the previous of 1 is again another multiply by 1/2. And you can see that the next one will also be a multiply by 1/2. Since it multiplies by a common value each time, this one is geometric. So next up we have two calculations involving factorials. Remember, if you see anything like in factorial, that means you start at the integer in and you multiply by all the preceding integers until you get down to 1. So for instance, when I see 5 factorial over 3 factorial, for the top I'm going to start at the integer 5 and I'm going to multiply all the way down through the previous integers. So 5 times 4 times 3 times 2 times 1. Okay, that's good for 5 factorial. Then we do the bottom. 3 factorial. Remember, factorial is the name for this exclamation mark in math. Start at the 3, multiply through the previous integers till you get to 1. And at this point, you could either type both of these in your calculator, or we could do some cancellation here, because we notice that we have a 3 on the top, a 3 on the bottom, with just multiplication above and below, so they cancel. Same with the 2, same with the 1. And this is just 5 times 4, which is 20. Now let's compare this to our next example. Do you see in the first example it was 5 factorial, 3 factorial? But here we have 8 divided by 2 in parentheses first, and then you apply the factorial. by order of operations, you have to do parentheses first. So I would first figure out what is 8 divided by 2. Well, that's 4. And then I apply the factorial. So I get 4 times 3 times 2 times 1, which is, I believe 4 times 3 is 12, times 2 times 1, which will give us 24. So in this next problem, we have a sequence, and we've been given the first term, and then I have a formula to find all later terms. And this is our recursive sequence, because it's building future terms based on previous terms. And we're asked to find a sub 2, a sub 3, a sub 4. Remember these subscripts, the smaller numbers written in the lower right-hand corner, are indicating the fourth term, the third term, the second term. Now we have the first term and we have a formula. So we can use this. If I want to find the second term, by the way the formula works, everywhere there's an n, I'm now going to plug in a 2. A sub 2 is a sub 2 minus 1 plus 2. And I think it's helpful to write out the formula and then you can fill in the details. Well, a sub 2 minus 1, 2 minus 1 is 1. That's a sub 1. We know what a sub 1 is. A sub 1 is 5. Right, so we'll replace that. So we get our 5 plus 2, and we get 7. So a sub 2 is 7. A sub 3, following the formula, everywhere there's an n, there's now a 3, is a sub 3 minus 1 plus 3. Now 3 minus 1 is the same as a sub 2 plus 3, but we know what a sub 2 is. It's 7. So this is 7 plus 3, which is 10. A sub 4, everywhere there's an n, there's now a 4. A sub 4 minus 1 plus 4. A sub 3 plus 4. A sub 3 was 10 plus 4, and we'll get 14. So we have another formula, and we're asked to find some various points in the sequence, the first, second, third, and 23rd term based on this formula. So I'm just going to write out the formula for each one. Now everywhere there's an n, I'll plug in a 1. So there's n's in these locations. Those get replaced with 1s for the first term. A sub 1 is negative 1 to the 1 times 1 plus 5. Negative 1 to the first power is negative 1 times 6. I'll get negative 6. A sub 2, notice this one's not recursive. This is an explicit formula because it's not based on previous terms. Negative 1 to the second power times 2 plus 5. Negative 1 squared is positive 1 times 7, and we'll get 7. A sub 3 is negative 1 cubed times 3 plus 5. We'll get negative 1 times 8. Negative 8. Now a sub 23 would be negative 1 to the 23rd time times 23 plus 5. And if you're uncertain here, remember negative 1 to an odd number will always end up being negative 1, because every odd number you can think of it as an even number plus 1. The even part of the exponent will always multiply itself out to be positive, and then you have that 1 left over that will turn it negative. And any negative number to the even number exponent will end up being positive 1, because the even number can be paired into negative 1 times negative 1 is positive 1, and you can keep doing that because there's always going to be another pair to an even number exponent. As this is an odd number, I know this will become negative 1 times 28, and we get negative 28. So here we are told that we've been given an arithmetic sequence. Now this is key, because we know arithmetic sequences add a common difference each time. The first term is 2. They're giving us all this key information. The common difference is 5. Now, at this point, we should either memorize the arithmetic sequence formula or definitely have it written on our formula sheet. I've included it here as a review. So I know the general formula for arithmetic sequence is always the first term plus n minus 1, that's part of the formula, times the common difference. Now we know the first term is 2, plus n minus 1 is part of the formula. The common difference here is 5. And this will give you the nth term for any part of this sequence. Now we care about the fourth term, so I'm going to plug in a 4 for everywhere there's an n. 2 plus 4 minus 1 times 3. And we'll get 11 for the fourth term. Excuse me, I just realized I made a mistake. Hopefully y'all caught that. Do you see how this 5 rewritten as a 3? Copying error on my part. I think my the 4 minus 1 and just rewrote it. But this should have been 5 carried through, which would then of course carry down here as a 5. Now this one's still a 3 because 4 minus 1 is 3. That was right. 3 times 5 is 15, and that should get us to 17. So I do apologize for that error. It was not intentional, but it's a good reminder to always check as we copy down that our writing is not getting ahead of our thinking. So next, if we were given this problem, find the value of this sum. And here I've given us a helpful reminder to find the sum of the first n terms of our arithmetic series. This is from our notes as a reminder. It's not given as part of the problem. We would want to bring this knowledge into the problem, either by remembering this or writing it on our formula sheet. So as I look at this sum, do you see that 60 to 64 is a plus 4? 64 to 68 is another plus 4. This is another plus 4. That tells me I've got an arithmetic sequence. Okay, and my common difference here is 4, and my first term is 60, and I want to know what this sum is. Now normally I would just have to keep adding, okay, 60 plus 64 plus 68 plus 72 plus 76 plus 80 plus 84 plus 88, on and on and on until I get to 124. And that would definitely work, but it would be a bit time consuming, and I'd likely be making a calculator error somewhere because I'm typing in so many things to my calculator. Instead, I could remember that we have this helpful formula for if you've ever got a series in an arithmetic sequence that's being added all together, you can find the sum of the first n terms using this formula. The sum of the first n terms is said to be the number of the term that you're looking at, the last one, times the first term plus the last term divided by 2. First term, last term divided by 2. Now right off the bat we can quickly plug in the divided by 2, the first term 60, the last term's 124. The only thing we've got to figure out is this n. Basically we've got to figure out this is the what term, the nth term, and all you know is this is starting off as the first term. Now while you could definitely just count again, figure out how many terms you get till 124, that's going to take time. There's a faster way to figure out what term it is. You first figure out how much distance did this travel. To get to here, 60 to 124, well I could just subtract 124 minus 60. That traveled 64 in all, but each jump is plus 4. So 64 divided by 4 means it jumped 16 times. We did this plus 4 16 times. So you did this 16 times of adding 4 to get to 124. So that might make us think, okay, so 124 is the 16th term. But we have to watch out. We added 4 16 times, but we started at the first term. So then we added to the second term and the third term, all in all 16 times. So our n is actually 1 plus those 16 jumps, or 17. It's the 17th term. So again, how do we find this 17? We said, well, in all, to go from the first to where we ended, I had a total distance of 64. Since I jumped by 4s, that's 16 jumps. Now those 16 jumps get added to the original 1, and that means I'm at the 17th term. So now we calculate our value. 60 plus 124 equals 184 times 17 is that number, divided by 2, and our answer is 1564 using this formula. So next we're asked to find the sum of this infinite series. I quickly glance and I see it's not arithmetic because it's definitely not adding and subtracting the same amount each time. I look and check, is it geometric? Well, to go from the first term to the second term, I would be dividing by 2. Let's see if that makes sense. I would divide by 2 or multiply by 1/2. Next one, I'd also divide by 2. We could check in our calculator each time I divide by 2 or equivalently multiply by 1/2. So this is geometric. And now that I know it's a geometric series that I'm adding forever and ever, I remember this helpful formula from our notes that I could either memorize or have written down on my personal formula sheet. If you've got a geometric series that you're adding together all the terms, then that is equal to the first term divided by 1 minus the common ratio. Now here, the common ratio is always what you multiply by. So even though I said dividing by 2, I want to rephrase that as multiplying by 1/2. Those are the same things. Dividing by 2, multiplying by 1/2. The reason I want to rephrase this is because the common ratio is what you multiply by. So in each case, I did multiply by 1/2, so my common ratio is 1/2. My first term is 4. So the sum for this is 4 divided by 1 minus 1/2. Well, 1 minus 1/2 is 1/2. Sorry, I'm mixing all those up. 4 divided by 1/2. 4 divided by 1/2 is 8. So my final answer here is 8. So here we were given a parametric equation, and we're asked to eliminate the parameter t and write it as a Cartesian equation. Remember, Cartesian equations are only in x and y. So the goal here is to solve one of these equations and get t by itself, and then substitute that in the other one. And generally we say, okay, how do you know which one to solve for t? Whichever one looks easiest. Looking at both of these, are both straight lines. One doesn't seem particularly more difficult than the other. So I'm going to just start off by solving for t in the first one. So I have x equals 5 minus t. I want to get t by itself. Personally, I'll add t to both sides so I can get rid of that negative. I get a x plus t equals 5. I want to get t by itself, so now I subtract a x from both sides. And I get t is equal to 5 minus x. Now this was helpful to us because now everywhere there's a t in the second equation, I'm going to substitute my 5 minus x, making sure to use parentheses so everything's properly copied. Y equals 8 minus 2. Now here I'm going to do parentheses 5 minus x, and this ensures that I multiply the negative 2 to both parts of this term. Y equals 8 minus 2 times 5 is 10, minus 2 times x is a positive 2x, and this will give me negative 2 plus 2x. So y equals negative 2 plus 2x is an equivalent form of this parametric equation set in a Cartesian equation. And again, keep in mind, if this is a quick solution, this review is meant to identify areas to study further, and you can always go back to our lecture videos on the topics that are much more lengthy and detailed and have a variety of examples. So consider the parametric equations x of t, y of t. Fill in the table below. Glancing at the table, I see I've been given t values. And for the first one, I don't have the x value, but I have the y. So I just have to find the x value when t is 2. And for the next one, when t is 4, I need to find the y value. So when t is 2, I need to plug that in to my x of t equation, because I want the x value, x equals, okay? x of a t-value of 2 is equal to 2 times 2 minus 4. 2 times 2 is 4, minus 4 is 0. So I'd plug in a 0 for the first one. Now I want to find the y value because I'm looking for the second term when t is 4, so I'm going to plug that into this one. Y when t is 4 equals 4 plus 3, which is 7, so I'll type in a 7. So next up, we're asked to sketch the curve along with its orientation for this parametric equation and then select the correct answer starting from t equals 0 to t equals 3. Before I look at the answer choices, I'm always going to sketch this on my own, and then I'll check which answer lines up with mine. So t is equal from 0. I'll say this is 1. This is 2. This is 3. And here I just made a common mistake. I'm so focused on graphing in terms of x, I started plotting out x's 0, 1, 2, 3, but these are t values. So I can't just assume the t values align with x values. How do I find the x values? I plug them into here. So I've got my t, my x, and my y, and this will help me plot my points. I'm going to plug 0, 1, 2, and 3 into my t value. Let's get the x values first. 0 into here. 3 minus the absolute value of 0 is 3 minus 0, which is 3. 1 plugged into here. 3 minus the absolute value of 1 is 3 minus 1, which is 2. 2 into here is 3 minus absolute value of 2, which is 3 minus 2, which is 1. Finally, 3 minus absolute value of 3 is 0. So that's the x values. Now I'll repeat that again for my y. 0 plus 2 is 2. 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5. So let's plot these, and how do you get the orientation? Is you start from time t equals 0. So where does the graph start? It starts at x equals 3. 1, 2, 3 in the x, and it goes up 2 in the y. 1, 2. So it starts here. Okay, so this is my start. And then it goes, when t is 1, to 2 in the x, but now up 3 in the y. And then it goes 1 in the x, but 4 in the y. And then it goes all the way up to 5, 0. So this looks like a straight line to me, but the orientation, remember, I started here and I went upwards. That's key. So when I look at these answer choices, which one of them hit the y-axis? Well, C and D are out. They don't even hit the y-axis. They're skewed off. But the difference between A and B is A starts high and goes low, but we know we started low and went high. So B would be our answer choice. So here we're asked to sketch this curve along with its orientation for a parametric curve given the x and y values. And I notice 0 to 2 pi, this is in radians, so make sure your calculator is in radian mode. So I need to make my chart of my t values, my x values, and my y values. And I'm going to start at t equals 0. I'm going to end at t equals 2 pi. And I'm just going to figure out fractions of pi's around that. So I'll definitely include pi, but let's also include pi over 2, pi, 3 pi over 2 at least, and then we'll plug in other points along the way. So like this is half of a pi, a whole pi, 3 halves of a pi, and then 2 pi, of course. So we're kind of getting fractions up to 2 pi. These are common points to plug into trigonometric equations. Now I'll need to get my calculator. Now right now, do you see my calculator's in degree mode? I need to change it to radians. Do that for your particular calculator, however you can do so. And I'm going to plug in 0 into cosine, and then I multiply it by 2. because that's what the x equation does. And it tells me my x value is 2 when t is 0. Similarly, we'll calculate the for sine of 0. So I plug in 0, sine times 4, and we get 0. So that's our first point. Now for pi over 2, pi divided by 2, cosine of pi over 2, however this works for your calculator, then multiply by 2, we get 0. Pi over 2, plug that into sine, multiply by 4, and I get the 0.4. Now at pi, I'll plug that into 2 cosine. And I get negative 2. Plug pi into sine times 4, and I get 0. 3 pi over 2, plug that in to each of the formulas. Messed that one up. Get negative 4. And the final point, at least at first, to see if we've got enough that is visible. Okay, so let's see how these points help us. So always start the t as 0. Make sure you know that's where you started. So we go it to x is 2. And then y is 0. That's our starting point. So I'm going to make this my start. And then I went to x is 0 up to 4. Next point. So I'm going to remember I went that way. And then I went negative 2 to 0. And then I went 0 to negative 4. And then I went back to 2, 0. So here it looks something like this. And then I've got to make sure I mark my orientation. And while I could definitely plot more points and be more precise, we're looking for, do we have the basic points? Do we have the orientation? And if this was multiple choice, I could definitely select the one that matches this general shape and this orientation. So here we're asked to consider the equation of the circle given below, find the radius. Now if we recall, the general formula for a circle that I've got included here for reference is this. The radius is always whatever the number is the whole equation's equal to, if we have x's and y's solved on one side, numbers on the other. So this 36 fits our r squared. So r squared is 36. To find what the radius is, I square root both sides. The square root of 36 is 6, so our radius is 6 here. So definitely include these formulas involving our conics if they're not memorized. Now for a parabola, here are 2 key equations, and just to help us visualize, I've included this in the graphic as well, but the equations are what's key. Y plus 1 squared equals 4 minus x. They want us to find the focus. So I look at my formulas that I either have memorized, but for these I'd really recommend them clearly written on your formula sheet. The focus is found here based on whether the equation is y something squared or x something squared. Because it's y something squared, I know I'm dealing with this top row for this problem. So the formula is always y minus k for this type equals 4p times x minus h. Now notice the formula expects this to be a minus, but do you see this as a plus? When the formula expects a minus but you see a plus, that's telling you that you had y minus what could turn it into a plus 1, a minus 1. Okay, my 4p, 4 times what gives you 4p? Only if p is 1. We're using the formula to find the pieces x minus, 8, that's pretty straightforward, x minus 8, x minus 8. So my k is negative 1, my p is 1, and my h is 8. And I extracted this from knowing how the formula works. And now the focus is h plus p comma k. So our h is 8 plus my p of 1 comma my k of negative 1. My focus is at 9 comma negative 1. So here I'm given an equation. I'm told it's a hyperbola, and I'm asked to find the vertices. So I recall the two formulas for the hyperbola, either if it involves the x term being the positive term minus the y term, or the y term being the positive term minus the x term. Here I see I've got my y term first minus my x. So I'm going to be dealing with this type of hyperbola. I find it's helpful to write out the basic formula first so I know what I'm expecting. That way I can label and identify my terms, extract from the formula. And the vertices are h comma k plus or minus a. So once I know what k, a, and h are, I'll be able to find this. So I see I've got, instead of a y minus k, what do I have? A y plus 4. If you're expecting a minus, but there's a plus, it's because you had to be subtracting a negative number. Y minus what gives you a y plus 4? Y minus negative 4. So that tells me I had a y minus negative 4 in place of my k over. What squared gives you 100? Well, you could square root 100 and you see you get 10 squared. Minus x minus h is expected, and I have x minus 3, so h is clearly 3. That one's straightforward. Over 64 is b squared. Square root of 64 is 8, so 8 squared equals 1. So those are all my little details. So that means k is negative 4, a is 10, h is 3, b is 8. Now notice I wrote h is 3. Even though there's a minus here, that's okay. Minus is part of the formula. That's expected. The reason k is a negative 4 is because negative is part of the formula. However, I had to subtract a negative number in order for it to become a positive 4. Now my vertices are found at h comma k plus or minus a. So that would be at h, which is 3, comma, k is negative 4. Let's do our minus a of 10, and 3 comma negative 4 plus 10. Negative 4 minus 10 is negative 14, so that's 3 negative 14. 3 comma negative 4 plus 10 is a 3 comma 6. So last up, we're given an equation in our Cartesian form, x squared, y squared, xy, all of this. And we're asked to describe, is it a circle, parabola, ellipse, or hyperbola? Now this reminds me of a key part of our notes that I've included here for reference. This would definitely be important to have written down on your personal formula sheet. It's that if you ever have a graph in this form, then you can tell whether it's a circle, parabola, ellipse, or hyperbola based on the coefficients a and c and how they act. Now a is the x squared term, c is the y squared term. So this is my key. This is the x squared, so that's my a. Negative 1 is my c squared. So c is negative 1. A is 3 because that's the coefficients in front. That's how this formula works. And it says, you'd look, okay, if A is equal to C, it's a circle. Now, 3 is definitely not equal to 1, so it's not a circle. Okay, next it says multiply a and c. Well, okay, that's 3 times negative 1. I get negative 3. That's not equal to 0, so it's not a parabola. It is less than 0, so we're not an ellipse, which is supposed to be positive. It's less than 0, which means I have a hyperbola. So that is it for our Exam 3 review video. I hope this was helpful in identifying areas of further study. If you're unsure why you missed a problem, remember you're always encouraged. You can send me a picture of your work. I can give more specific feedback. You can also go back to our original lecture videos and lecture notes, and you'll find a variety of examples of each of these topics that are explained in thorough detail. You can go to our online textbook and try odd-numbered problems. Check your answer in the back of the book, and always reach out as you have questions as you're preparing. I'm very happy to help you, and I hope you have a good evening.